Good morning, good afternoon, Team Impact. A couple of housekeeping things. I know some of you are still working on your test, or if you're getting to the video, or some are working on the video right now, right out of the gate. While you're working on this, I'm going to be passing back your quizzes and going on. But anyway, we are moving on to fraction operations, Unit 2. This is going to get a little bit more challenging here than the first one. So I hope you did well on your test. We are going to continue working and stay with me here. So let's get after this thing, and here we go. So open up your packet. Let's go ahead and put our name and period up there and flip it over. Okay, and this one's pretty thick, so we're going to be in this for a few weeks here. Okay, today we're going to be chatting about factors and multiples. Factors are numbers that make up a product, right? Factors are 2 times 3 is 6. 6 is the product, 2 and 3. Multiples are when you count by a number. So if I wanted to know the multiples of 2, I would count by 2's, right? 2, 4, 6, 8, 10, and so on. If I want to know the multiples of 7, 7 times 2 is 14, 7 times 3 is 21, and so on. So that's really the difference of those two things. We're going to get into some different things here. So let's get after this thing today. All right, stay with me, please. A number is composed of other numbers called factors. For example, 2 times 3 is 6. 2 and 3 are the factors of 6. 6 is what we call the product, the answer to a multiplication problem. And that's where our vocabulary is coming in from our rapid fire. When a set of numbers has the same factor, it is called a common factor. Okay? The greatest common factor, or GCF, right? And I'll let you write that down, is the largest factor that has a set of numbers, all right, in common. Okay, so the vocabulary is kind of out of the way. Let's go ahead and take a look at this. We're going to go ahead and factor tree these down, all right, and then we're going to go ahead and share these with a Venn diagram, just to let you see it. I don't expect you to use a Venn diagram when we get into this, and make sure I'm moving this up. So the factors of 15 are 3 times 5, right? And I circle those, okay, because they are what we call prime numbers. Prime. A prime number, all right, P-R-I-M-E, Mike. A prime number has 2 factors, 1 in itself. So the only things that will make up 3 is 1 times 3, and the only things that make up 5 is 1 times 5. All right, conversely, if we go over to 60, we're going to have both prime and composite numbers, but we only want to circle the prime numbers. And let's start with 6 times 10, okay? Both of those are what we consider composite numbers. We won't circle those, okay? So because 1 times 6 will make 6, and 2 times 3. So I'm going to go ahead and factor this down, and it doesn't matter where you start. Some would say, well, hey, 5 times 12 works. Yeah, you could go with that. Or 2 times 30 works. You could go with that. So I just kind of start with 2 numbers that are kind of even. They're a little bit more manageable with me. All right, what makes up 6? 2 times 3. Why did we circle them? Because they are prime. I'm done over here. Let's factor out 10. 2 times 5. And we'll circle that. Okay, so these are all prime numbers. They only have 2 factors, 1 in themselves. Now, okay, if we look over here, all right, what do we have here? Under 15, all right, we have a 3, and look here, under 60, we have a 3. So I'm going to put that in my Venn diagram where there's an overlap, because it occurs both in 60 and 15, all right? And I'm going to go ahead and cross those off. Again, we're only going to do this once today, all right? Another common factor is 5 and 5. So I'm going to put that in the overlap, okay? So we have 3 and 5. The other two factors are 2, and I'm going to write those in the 60 side, okay? Because they're the only numbers that appear in the 60, and they don't appear in the 15 factorization, all right? So that's looking at our Venn diagram. Our common factors of 15 and 60 are 3 and 5, okay? All right, I don't want to go too fast. I want to give you a chance to get caught up. Now, the next piece is the ladder method. All right, I don't use this, but I will show this to you in case you like it, okay? So what we're essentially doing is writing a division sign upside down, and I'm going to put a 2, okay? And I'm going to put an X. What times 2 is 20, 10. What times 16 is, what times 2 is 16, and I would put an 8. And what we would do is put another bar like that. And we're going to go ahead and factor those two down again. All right, and I'm going to divide both of these by 2, and I'm going to put another X there. Okay? And I'm going to factor these down because what times 2 is 5? What times 2 is 8? 4. Okay? Now, we're looking at this. Does this go into both of these numbers? No. But guess what? 4 goes into both of these numbers. So therefore, it is what we call prime factor. It's not a prime factor, but it is the greatest common factor, okay, that would go into both of those. Okay? Let's try that again. Let's divide both of these by 2. 24 divided by 2 is 12, and 40 divided by 2 is 20. All right, and let's factor it down again. What goes into 12? Let's divide them by 2. They're both even, right? Our mental divisibility rules. Okay, and I made a mistake over here, and I'll clarify that in just a second. All right, what times 2 is 12? 6. What times 2 is 20? 10. Can we go again? Yes, those are both even, so I'm going to put another one down. Times 2. What? 3 and 5. Now, let's go back over here for a second here, and I'm going to erase this X, okay? All right, to get the GCF of those two numbers, which is 4, we take 2 times 2. To get the GCF over here, we're going to take 2 times 2 times 2, and we're going to get 8. It's been a while since I've done that, so I apologize. So that's just another way to find the greatest common factor using the ladder method. So if you like that technique, you can go with that. And the reason we stopped over here is because there's not a common factor that will be both of these are divisible by. So I knew I was done. Okay? I knew I was done. All right. So let's go down to the next problem here. I'm going to go back to the tree method, the factor tree method, because I like that better. If you like this technique, go ahead. So I'm going to list the numbers 24 and 6. And I'm going to factor those down. We're looking for the greatest common factor of both of these numbers. So the GCF, I'm going to factor it down by 8 and 3. Are either one of those prime? Yes, 3 is prime. Factor this down, 2 and 4. Are either one of those prime? Yes, 2 is an even number, and it's the only even number that is prime, 1 times 2. And let's factor this down, 2 times 2, and there we have it. Let's go over to 6. We have 2 times 3. 2 times 3 is 6, and they are both prime. Okay, so we're looking for the greatest common factor here, okay? So to do this from a factor tree, which is what I recommend, I'm looking for numbers, okay, that appear in both lists. So I have a 2 and a 2, I'm going to write that down, times. Do I have another 2? Yes, but no other 2 over here, so I don't write that down. But now I'm going to come to the 3. I have a 3 and a 3, I cross those off, and I write that down. I'm out of numbers under 6. So therefore, I am done. 2 times 3 is 6. 6 is the greatest common factor. I recommend this technique. Let's go again. Now we have a triple stack. And in our triple stack, we have to do a little bit more work. First number's 18. 6 times 3, I circle 3, and I factor 6. 3 is prime. 6 is what we call composite. Composite. Next number up is 2 and 3. I circle both of those. We are done because I can't factor any more of those numbers down. I'm going to draw a line to separate, and I'm going to go to the number 24. 6 times 4. 2 times 3. Those are both prime numbers. They only have 2 factors. And 2 times 2, and I'm going to circle those. Okay? And I'm going to draw a line and go to the number 60. Again, what we're looking here for is the greatest number that's going to go into all 3 of these numbers evenly. That's what we call the greatest common factor. Okay? So I'm going to start with something pretty even. 10 times 6, 2 times 5. They are both prime. And then finally we have 2 times 3, and circle those. We are done factoring. We have nothing but prime numbers. So now I'm looking for numbers that appear in all 3 lists, that are common in all 3 lists. So let's start with a 2. I see 1 there, 1 there, 1 there. I write it down and put a dot. The dot means to multiply. Okay, I go to a 3, I go to a 3, and I go to a 3. And the reason I went to 3, because I had no more 2's there. It has to appear in all 3 lists. Let's check our last number, or our last digit, that is 3. Here's a 3. There's no other 3's here. I'm done. I don't even need to look at the 60 factor tree. So let's go ahead and multiply through. 2 times 3 is 6. And 6 is our greatest common factor. So let's press and pause here for a second and review what we have done. We factored the numbers down, all right, to prime factors, to prime numbers. I circled the numbers that were prime, and then I found the number that was common in all 3 lists, and I wrote it down. I crossed them off. I looked at my 3's. They were common in all 3 lists. There were no other numbers common, so therefore I multiplied these 2 numbers, and the greatest number that goes into 18, 24, and 60 is 6. Let's continue on. Multiples. Multiples, okay? All right, let's go. Oops, there we are. A multiple of a number is the product of multiplying that number by another number. The answer to a multiplication problem. The first 5 multiples of 7 are 7 times 1 is 7. 7 times 2 is 14. 3 is 21, 28, and 35. The power of math facts. That's why I keep hammering on you with those. The least common multiple is the smallest common multiple a set of numbers has in common. Okay? So really the math facts are really going to help you here. Let's go. We're looking for the least common multiple of 4 and 9. We're going to list out the first 10 multiples of each, I think. Yes. Now, do you have to go 10? No, I usually go 5, but we'll go 10 in this case. So let's count by the numbers here. 4 times 1, times 2, times 3, times 4, times 5 times 6 times 7. 7 times 4 is 28, and 32. I've run out of room. I'm going to stop there. I may need to go further. I don't know. Let's list the multiples. Now, I always start with the smaller number, and then I go with the bigger number, and you'll see why in just a minute. There's no 9. So let's list the multiples of 9. 9, 18, 27. 9 times 4 is 36. 9 times 5 is 45. 9 times 6 is 54. 9 times 7 is 63. 9 times 8 is 72. Now, let's pause for a second and see if we can find something that's common in both lists. Nothing, nothing, nothing. 36, no. I'm already above that. But guess what? The next number after 32 is 36. And if you look at this, the first number that's common in both lists is 36. So that's what we identify as the least common multiple, 36. Okay? Now, it's a coincidence. A lot of you will say, well, hey, 9 times 4 is 36. That will always give you a common multiple, but not always the least common multiple. Okay? Let's go. 3, 6, 9, 12, 15, 18, 21. I think you can see what the common multiple is going to be here. 7, 14. Oh, right there it is. No reason to go any further. And there you have it. So the first number that appears in both lists is 21. 21. Good stuff so far. Okay. All right, let's take a look at these problems and see what we're getting into here. All right. Amari and Ethan planned an end-of-the-season soccer party. They purchased 45 hot dogs, all right, and 30 individual bags of chips. Okay. Now, if each person will receive the same amount of food, what is the greatest number, greatest, GCF, of the number of people that they can feed without having any leftovers? So giving away both, right? Okay. So we're going to look for the GCF, all right? So I'm going to go ahead over here and factor these, 45 and 30. 9 times 5, 5 is prime. 3 times 3, 3's are prime. Let's come over to 30. 5 times 6, that is prime. Some of you may have started with 3 times 10. 3 times 2, those are prime. Okay? Now, we're looking for numbers that appear in both lists. Here's a 3, here's a 3. Write it down. No other 3's over there, but guess what? There are 5's in both lists, so I'm going to write it down, and we are done. 3 times 5 is 15, and, all right, the question is, what is the greatest number of people that they can feed without having? 15 people. 15 people, okay? All right. How many will each receive? Well, let's think about this, right? Each person can get 3 hot dogs and 2 bags of chips. And 2 bags of chips. But you say, well, how does that work, right? Well, our hot dogs are 45. 15 times 3 is 45 hot dogs, right? So what number times 15 is 45? 3. What number times 15 is 30? 2. And there is your final answer. We have one more problem. We're pretty deep into this video, so let's take a look at the last piece. Okay, the Valquez family visits their grandmother every 3 weeks and hosts a neighborhood party every 8 weeks. Every 16th week, the Valquez family takes a day to go hiking. First question. After how many weeks will the Valquez family visit both their grandmother and host their neighborhood party? So in this case, what we're looking for is the LCM. We're going to count by that number, right? So we want, all right, visit both their grandmother and host a party. 3 and 8. So we're looking for the least common multiple of those two numbers. 3, 6, 9, 12, 15, 18, 21, and 24. I think you're going to see what the common multiple is right out of the gate, and there it is, right? There it is. So, how many weeks? 24 weeks. After how many weeks will all three events occur? All three events. So now, all right, we're going to add a third number to this, right? And the third number is the 16. So if I drew this out and put 16. So we're looking for the first number that's going to be in all three lists, right? So let's continue. 16, is that in all lists? No. All right, excuse me. 32. 32 here. All right. Is that going to be in all three lists? No, because the next one here is 32, but 3 does not go into 32. All right, let's go one more, 48. And guess what? 16 times 3 is 48. 8 times 6 is 48. And remember our mental divisibility rules? 8 plus 4 is 12. Does 3 go into 12? Yes, 3 will go into that number. So after how many weeks? 48 weeks. Okay. Good start to the day. This video is online, so you can watch it again if you would like. Let's flip the page. This is your homework tonight. Numbers 1 through 9. 1 through 9, okay? So, I've given you multiple ways to find it. I would stick to the factor tree method, all right? We're factoring, we're listing the multiples, and so on. Have a great day, guys. I'll see you.